Hi, this is Maggie. In this video, we're going to design and code a small inheritance hierarchy in Java. In the example, we'll have subclasses, also called derived classes or child classes, that extend a superclass, also called a base class or parent class, and we'll also create an interface class that two of our classes can implement. We're going to consider a library checkout system. I have here a sequence diagram showing the classes involved in a borrow use case. If you aren't familiar with sequence diagrams, you might want to watch the 2 Java sequence diagram videos on this channel. I'll link them in the description, and I'll put a link into the first one here. Let's look at the sequence diagram because this will inform our inheritance hierarchy. External to the library object, the borrow message is sent with a patron ID and an item ID. That would be the patron who wants to borrow the item and the item. The library will use some sort of verification to find the patron object and item object that match this request, and will then determine if the item can be borrowed. For example, is it a book, DVD, museum pass, or item from the Stuffbrary, which can be borrowed, versus is it a reference book or newspaper, which can only be accessed within the library. If the item is borrowable, then the system will check whether it's checked in and can therefore be checked out. And if it's checked in, then the system will get the fee from the item for borrowing and check it out, which will return the due date, and then it will send the borrow message to the patron with the item, fee, and the date the item is due, so it can be added to the patron's account. This is an oversimplification of the use case, the system's functionality, and what classes might be involved here, because I want to focus on inheritance in this example. So please forgive anything that seems contrived or oversimplified, and recognize that this is an example meant to illustrate uses for the different kinds of inheritance in Java and implementation of inheritance in Java. One thing that may have struck you if you've ever used a library is the fee. There's no fee for borrowing books, generally, but other things can be borrowed, such as museum passes and DVDs. At my library, DVDs have a fee. Museum passes usually don't. Usually you pay a fee at the museum if it's not a free pass. But my library also has a Stuffbrary, and let's imagine there's a fee for borrowing an expensive item such as a musical instrument. Items also have different due dates, and for example, a book will be automatically renewed if nobody has a hold on it. So there are different rules for different kinds of library items, perfect for an inheritance hierarchy in which all items respond to the same messages, but each derived class handles the message a little differently. In addition, patrons have library cards with a barcode, and library items also have barcodes. So there are 2 different categories of item that might have barcode-related functionality. I've written something called verify into this use case, imagining that the patrons and items don't freely share their barcodes, but will verify if the barcode passed into them matches theirs. Here's a class diagram showing an inheritance hierarchy for our library item classes. Let's focus on the library item inheritance hierarchy first, and then the verifiable interface. So in the library item hierarchy, the superclass, library item, besides having a constructor that takes the ID as a parameter, responds to the isBorrowable message and will return false. There is then a subclass called Borrowable, which will override this message to return true, and will also respond to isCheckedIn, getFee, and checkout messages, as well as the constructor. This is an abstract superclass, as we'll never make an instance of Borrowable. We will only create instances of the 4 subclasses. The method getFee is abstract. However, we will have a checked-in field that Borrowable will maintain, and we'll initialize that to true, and return it from isCheckedIn, and we'll set it to false in checkout. We are also returning a dummy due date from this method. Another option for this functionality would be to have a separate getDueDate method. We can imagine that as we build the class, we'd add a method for checking an item back in, and the borrowable object could implement that by setting the checked-in field to true. There are 4 borrowable subclasses: book, DVD, museum pass, and stuff, and they all also respond to these messages, except for isBorrowable, which is handled in the superclass, and isCheckedIn, also handled in the superclass, and they also have constructors. Now we have an interface which I have called Verifiable, and that has one message, verify. The reason that I've made this an interface and not part of our inheritance hierarchy for LibraryItem is because we have both the patron class and the LibraryItem class that will implement this interface, and they are not otherwise related. That's a good situation in which to use an interface class. An example of an interface class in the Java API is serializable, which allows you to create a binary form of an object for writing to a file, for example. We want this functionality for many different kinds of objects, so it is part of an interface that different classes can implement, even though they're otherwise completely unrelated. Now, let's look at some code for this system. I have a partial implementation here that is composed of the LibraryItem hierarchy down through book. We'll look at that and then implement one more subclass, and then we'll implement the interface and the patron class. These are quite empty classes, as we're only implementing what we learned from our one use case. Also, I have not documented these classes, but naturally they should be documented with complete Java doc. Here I think it is easier to see the code if we omit the documentation. Here is the LibraryItem class, and you can see that it has an ID field and a constructor that takes the ID as a parameter and sets the field from the parameter. It returns false from is borrowable. Here is the Borrowable class, which is a subclass of LibraryItem. We can see that in the header. Public abstract class Borrowable extends LibraryItem. When a class is a subclass or derived class, child class of another class, we write extends and then the name of the superclass, also called base class or parent class. This is also, remember, an abstract class, meaning there will be no objects of class Borrowable. So we write abstract after the visibility specifier. Now it has the one field that it maintains, the Boolean checked in. The constructor takes an ID as a parameter, and the first line of the constructor is to invoke the superclass constructor, passing in that parameter. That will execute the LibraryItem constructor, so that part of the object is in a stable starting state. The Borrowable constructor then sets the checked in field to true. Now isBorrowable returns true. This overrides LibraryItem isBorrowable, which returns false. I've put @override over the header for this method to communicate to other programmers that this method overrides a superclass method. This isn't necessary, but it is a good practice. Not only does it communicate to other programmers, but it also means the compiler will do a check to make sure this really is overriding a superclass method, which can catch a bug such as misspelling a method name. The isCheckedIn returns the value of the field. Checkout sets checked in to false and returns a dummy due date, the current date. This will be overridden in the various subclasses, which all have different due dates. For books, it's 2 weeks from the current date, for DVDs 1 week, and for museum passes 1 day. I'm not sure how long you check stuff out for in my library, but let's say it's 4 weeks. Now, getFee is not implemented here because there's nothing Borrowable is maintaining relative to the fee. It's really not the responsibility of this class to return a fee, so we're going to make that an abstract method, meaning it is the responsibility of subclasses to implement it. We could have designed the system differently, where fee was a field, like checked in, but I would like to leave the implementation of assessing that fee to the subclasses, in case it is not as simple as a single fee. For example, the stuff or museum pass subclasses might have ways of computing varying fees based on properties of the pass or item. So let's now look at book, the one concrete subclass of Borrowable that I've implemented here. It has a constructor that takes ID as a parameter, and it invokes super and passes the ID up. That will pass this ID up to the Borrowable constructor, which will pass it up to the LibraryItem constructor, then finish executing by initializing the field checked in, and then control will return to book's constructor, which does nothing else at this time. We could certainly imagine that this constructor might take additional information like title, author, type of book, etc., but for now it only takes ID. For getFee, as a book has no fee, we return 0. Remember that this method is in Borrowable, so I have an override tag over it, override. For checkout, we return the current date plus 2 weeks as the due date for a book. This also has an override tag. Now let's implement a DVD together. I'm going to right-click on our package and choose New Class, and in name I'll type DVD. In the superclass box, I'm going to write Borrowable, and then I'll click Finish. Eclipse puts in the extends Borrowable for me in the class header, and it provides a stub method for getFee, the abstract method that must be written if this is to be a concrete class. In the stub, it returns 0. I'm going to change that to return 0.5, a 50-cent fee for renting a DVD. It also puts the override tag in for me. I'm also going to write checkout, and I'm going to go copy that from book to save time, and add 1 week instead of 2 to the current date for the due date. Note that we have to import java.time.localDate for this class name to be visible. Now you can see I have a little error, and if I mouse over that, it says implicit superconstructor borrowable is undefined for default constructor. Must define an explicit constructor. What's that all about? In Java, there is an implicit constructor for every object that takes no parameters and initializes fields to default values, zeros for numeric types, and null for objects. If we have a derived class, it calls the superclass implicit constructor. As soon as we write a constructor, there is no longer an implicit constructor. And if we derive from the class, we have to write our own constructor because the derived class can't call the superclass implicit constructor because it doesn't exist. So DVD can't call Borrowable's implicit constructor because there isn't one. We'll write a constructor that takes an ID as a parameter and passes it up to super, as we did in book. At this time, there's nothing else in DVD we need to initialize, although we can imagine the object having additional fields as we develop it. Now we have one piece left to implement, and that's the Verifiable interface. So I will right-click on my package and say New Interface this time, and I will give it the name Verifiable. Eclipse responds by creating verifiable.java, and the header for the interface is public interface verifiable. Now I will write the method that is part of the interface, public abstract boolean verify int id, and then a semicolon, because it is abstract. Alternatively, we could have not made it abstract and had it return false, a safe response, but I prefer to make it abstract and require that it be implemented. Let's create a patron class, and for now, the only thing it does is maintain an ID and implement the verifiable interface. It's not part of our LibraryItem hierarchy. So we'll right-click on our package and choose New Class, and we'll name it Patron, and leave the superclass as java.lang.object, but notice we have a box for interfaces. We can list as many interfaces as we want our class to implement, as it can implement more than one. So let's click Add and choose Verifiable. Click OK, and click Finish. Eclipse generates a class for us which has, as its header, public class patron implements verifiable. Inside the class, it provides a stub for the verify method. So we can define a private int field ID, and we can write a constructor for patron that takes the ID as a parameter and sets the ID field. And then in verify, delete the to-do comment and write return this.id equals ID. That will return true if the ID that's passed in matches the value of the field for the object receiving the message. Now, we also want LibraryItem to implement verifiable. So we'll add implements verifiable after the name LibraryItem in the definition of the class. And when we do that, we can see Eclipse gives us an error that says we need to implement the verify method. We can copy and paste that from patron because it will be the same. I can see I called it verifiable, and I meant to call it verify. Now a class can both extend and implement. So if it were borrowable, for example, that was going to implement verifiable, we'd type implements verifiable after extends LibraryItem. We do not need to do that because it's implemented in the superclass, and if for some reason we needed to override it here, we could without adding the implements clause because it would inherit that interface from the superclass. Now, I'm going to quickly write a client class that I will call library to invoke some of these methods and demonstrate the functionality. I'll write a borrow method that will implement our sequence diagram, and then in the main method, I'll create some instances of library item, book, and patron, and invoke the borrow method. I'm going to put some print statements in the methods to make the execution visible. Okay, now I wrote the program and I saw that I omitted some very important code that I intended to write. So when I ran the program, I noticed that I was able to check a resource out that I had already checked out, and that is because I forgot to call the superclass checkout. That's a very important method. In Borrowable, superclass checkout sets checked in to false. So I need to invoke super.checkout here. Now this is going to return a date, but that was a dummy date that we don't care about. The important thing is that it sets the state of the object. So I need to do that in checkout in both book and DVD. And hopefully now, when I run my program, I will see that I cannot check out resource 1 twice. And you can see now it says item 1 is not checked in, so we don't come up with a new due date. All right, so the importance of testing. So let's take a look at this program. I have a public class library, and I've created array lists of patrons and items. And I just created 2 patrons, and they have different IDs, and I created a book, a DVD, and also a library item to represent anything that is not borrowable. So you can imagine that we might extend this hierarchy to include a not borrowable category, which would include the reference objects and maybe also newspapers, items like that. So I put those in the lists, and then I called borrow. I borrowed twice item 1, and that results in item 1 is borrowable, checked in, fee is 0, due date, and then item 1 is borrowable, not checked in. Then I also borrowed item 2, which is the library item, and it says nothing. Where's my message? If item is borrowable. Oh, that's, I got my curly braces mixed up there. There we go. Let's try one more time. There we go. Item 2 is not borrowable. Okay, and then item 3 we try to borrow, and that was a DVD, so it's borrowable, checked in, the fee is 50 cents, and that's a 1-week due date, and you can see for the book we have a 2-week due date. So in the actual code for borrow, for the most part, I implemented the sequence diagram. I did check to make sure that the patron and the library item returned from going through and verifying, so I really just a search where I asked each one if the ID was their ID and then returned that object. So making sure that they were non-null. I didn't test it with null values because that isn't really an interesting part of the use case. Once I determined they were non-null, I sent the is borrowable message, and if it was borrowable, then I sent the is checked in message, and if it was checked in, then I sent get fee and checkout. I did not do the part where we then tell the patron that they've borrowed the book because I didn't write that. It was more focused on the inheritance aspect of this program. One other thing. you'll notice that on lines 34, 36, and 37, I cast the item to the Borrowable class before I send the isCheckedIn, getFee, and checkout messages. That's because the declared type of item is LibraryItem. Once we've determined that the item is borrowable on line 32, we know that it's a subclass of borrowable, and we can send it the isCheckedIn, getFee, and checkout messages. But Java, when it's checking this statically, doesn't know that at runtime that object is going to be of the borrowable class. So that would throw an error if we didn't cast it to the class that we know it is if we've made it into this conditional code. So I am going to upload all of this content to my GitHub repository, and I recommend that you play with it, maybe walk through it in the debugger if it isn't clear exactly how it's working, and exactly when we call a method that we've overridden, how all of the pieces are being put in place by each of the classes, as we call the superclass implementations of those methods. What you can also do is implement the museum pass and stuff classes, which are part of the LibraryItem hierarchy and which I did not implement, but they would be excellent practice because they're going to be very similar to book and DVD. There will also be practice exercises in the description of this video, and I recommend you try those as well. Once you can do all of that, you're ready to move on.